Right, so finally question 14. Table below shows 5 statements that refer to isotopes and some radium isotopes. So we've got the smallest mass, most neutrons, largest specific charge, one which decays by beta decay to produce technetium-225, and one that decays by alpha to produce radon-220. Complete the table by ticking one box in each row to identify the appropriate isotope. The first row has been done for you, so they've already told us that has the smallest mass, obviously because 223 is the smallest mass number. Next one, isotope with the most neutrons. Well, that's going to be the top one over here because we've got the 226. So it's got to have more neutrons. The proton number is still the same. The nucleus which has the largest specific charge. The one which has the largest specific charge. They've all got the same charge. So we're looking for the one with the smallest mass, which is going to be, again, that one. One that's going to decay via beta decay to form actinium-225, actinium I think, sorry, not actinium. Beta decay is going to keep the mass number the same and going to add one to the proton number. So if it's 225, it has to be that. And one which is going to decay via alpha decay, that's going to take 4 off the mass number and 2 off the proton number. So if it's going to form 220, 86, that's this one because 4 off 224 is 220 and 2 off 88 is 86. Part B. An atom of one of the radium isotopes in the table is ionised so that it has a charge of plus 3.2 times 10 raised to the power minus 19. State what happens in the process of ionising this radium atom. Well, if it's got a plus charge, it must have lost 2 electrons. Each electron has a charge of 1.6 times 10 to the minus 19, so 2 of them makes 3.2. That would be our answer. Part 2, bit harder now, but not that difficult. What have we got to do? Specific charge is 8.57 times 10 raised to the power 5. That's coulombs per kilogram. We want to work out which isotope it's got to be. So the best way to do this is to calculate the mass. And then once we've got the mass, we can work out the number of nucleons and then identify the isotope that it should be. So specific charge is the ratio of the charge to the mass. So rearrange that equation. Mass is going to be charge over specific charge. Plug some numbers in for that. The charge is 3.2 because we've been ionised, so we've got plus 2 charge. 3.2 times 10 to the minus 19. And we're going to divide that by the specific charge which we're given, 8.57 times 10 to the power 5. I'm running out of room here, so I'm just going to put the answer down here and then move on. That gives me about 3.73 times 10 raised to the power minus 25. Okay, remember that number. I'm just going to create some space. So that's 3.73 times 10 to the power minus 25. That is the mass of the nucleus. To work out the number of nucleons in there, so I can identify it, I divide by 1.66 times 10 to the power minus 27. That is the average mass of a nucleon. And that gives me about 224.3. There's some significant figures errors here because you can't have 0.3 of a neutron or a proton, so it must be 224. So it must be this one here, 22488 radon, and that is your answer.